So we're going to start off with the power supply of the vehicle, and this is a battery. This is on an ATV. We have two posts, positive and negative. These come in different sizes for cars. We have batteries here. We have different styles of batteries. This is the same that produces less volts. And we have a power supply here, and it changes to DC voltage for our battery. So this board simulates a battery supply. With volts, DC, I can measure voltage across the battery. So like this simple C battery, I just put one lead here, one lead across the bottom, and it shows how many volts goes through that battery, so about 1.5 volts. The 9-volt battery, these square batteries, same thing. I can measure battery voltage across the two terminals, and it shows 9.6 volts. So just like any battery that we're measuring across for a car battery, regular small batteries, we can measure the electrical potential across this breadboard through the positive side and the negative side, representing 13.7 volts, which this is regulated at 3.8 volts. And every power supply is going to have to generate some sort of voltage. So we measure voltage, direct current with the V, the line here, and this is placed in common ground with volts here. So in a circuit, we have to have a power supply, which is batteries. We have to have wires. So we have some wires here that transfer the electricity through wires, and we'll have some sort of switch usually that controls the circuit. And these are a whole bunch of components across here that changes the value of electricity. But then we want to focus on this side here. These are loads. So clear over here, we have light bulbs. These are loads. So loads is what generates some sort of work. This generates light. This generates sound with the buzzer, and this generates some mechanical movement with the motor. So in a circuit, we're going to have battery, wires, switches, and a load. And we want all of that electricity to go to the load. This switch here, these different type switches will turn the circuit on and off. It closes the circuit or opens the circuit. So when I go up on, that's going to close the circuit. When I flip the switch, it turns off the electrical circuit and it creates an open across the switch. So any switch opens the circuit or closes the circuit to allow electricity to go from a power supply, which is a battery, then to a load. Relays is an electrically operated switch that controls circuits by opening and closing contacts in another circuit. Relays use electromagnets to operate their internal switching mechanisms. They are used to isolate circuits, switch between circuits, and control a high power circuit with a low power signal. A transistor is a small semiconductor that controls or regulates the flow of voltage or current. It can also amplify and generate electrical signals or act as a switch or a gate for them. Transistors are made of 3 layers: or terminals of a semiconductor material, each of which may carry a current. There are PNP and NPN type transistors having collectors, emitters, and bases. A resistor is a passive electrical component that limits or regulates the flow of electric current in a circuit. When a resistor is placed in a circuit, it reduces the amount of current flowing through it and lowers the voltage in a particular portion of the circuit. This drop of voltage is also known as a voltage drop across resistors. A capacitor is an electronic device that stores and releases electrical energy in a circuit. It's made up of two electrical conductors separated by a distance, which can be filled with a vacuum or insulating material called a dielectric. When connected to a power supply, electrons flow from the negative end of the terminal and build up on one plate of the capacitor. The other plate has a net positive charge, resulting in a potential difference. A variable resistor is a passive device that can adjust voltage or current of a circuit by sliding a wiper across a resistive element. The wiper can be made of carbon, nickel, chromium, tungsten, or other resistive materials. The wiper portion can be set to a fixed location on the circuit board, or it can be adjusted with a knob. A diode is an electric component that controls the flow of electricity in one direction. Though it has two terminals, there is an anode and a cathode. The diode conducts current when the voltage at the anode is higher than the voltage at the cathode by more than a value specified in a data sheet. This operation is called rectification and is the basic operation of diodes. Diodes are known to change alternating current to direct current, and light emitting diodes is a choice of lighting elements used today, replacing light bulbs. These light bulbs are all loads, so these generate some source of work or light. In this case, they're light, similar to our LED. It's generating light. And then we have a buzzer. Acts like a horn. So we have a load that becomes a horn. And then we have electrical motors, which is another load. And we want all of the voltage to go to the load. That's the primary goal, is we want all of the battery voltage to go to the load, and we don't want it to disappear before it gets to this load.